functions are all about cell boundaries. All cells are surrounded by a thin, flexible barrier called the cell membrane, which is also known as the plasma membrane. Oh, I have your notes right here. Now the good news is we're just gonna do a few pages of notes today, and then we're gonna get to our bubble lab, so. Let me know when you have this filled in. Alright, functions of the cell membrane are they maintain the homeostasis, which is a stable and healthy internal environment for the cell. They do this by providing support and protection to the cell while controlling what enters and leaves the cell. So it's like, see over here, this little meme, like a body bouncer at a club. Who's in the club? We all fam. You're not getting into my club. So the cell membrane. Cell membrane is selectively permeable. If something is permeable, it means that things can pass through it. The cell membrane is described as selectively permeable or semi-permeable because only certain substances, not all, can pass through it or enter and leave the cell. Any ideas why it would be important as to what could and couldn't enter the cell? Well, you don't want things that aren't supposed to be in there because it could kill and damage the cell. The reason that the cell membrane is selectively permeable has to do with its structure and what it is made of and how it's organized. So hydrophobic and hydrophilic are two words that deal with the cell membrane. Hydro means water and philic means loving, while phobic means fearing. So if something's hydrophilic, it is attracted to water, and if something is hydrophobic, it refers to a substance that avoids water. So the example here, if you take, let's say lemonade, a lemonade packet, and you mix it with a cup of water, it dissolves, right? So that is hydrophilic. If you take a cup of water and add oil to it, they don't combine. So it is hydrophobic. Kind of like, have you ever seen a lava lamp? The water and the oil just don't mix. So the cell membrane is made up of a phospholipid layer, which is two layers. One of the layers is a hydrophilic head and two hydrophobic tails. So hydrophobic tails are going to keep the water away, but a hydrophilic layer, or the head, is going to allow it to absorb. Do one more slide before we get into our lab. And so when we put it all together, this is what the cell membrane will look like. You good? Alright. So if you want to,
We don't have it.
you don't have it?
No,
Okay.
it's already filled out.
Right, yes, there's nothing to fill in for this one, you're right. Alright, so if you could, we'll pick up on the rest of the notes for tomorrow. We're gonna come over here and work on our lab. Bring your pencil, you don't need your notes.
Fill this out.
We're gonna fill that, the rest of that in, either after our lab or tomorrow, whatever we need to do.
This one I wrote.
Oh, that's fine. Rosie, do you mind grabbing the third, there's a triangle like this in the, like next to the comfy chair?
Yeah.
Do you guys have pencils?
I have two. I don't. Making my way. Is that my mom? Why is my mom here?
It's okay. All right. So for the first activity, it's going to show us how the cell membrane acts as a liquid and a solid. You'll be able to see the flexibility of the cell membrane and how it is able to take shape without breaking. So here we have the straws like this. Put your straw in your bubble solution. Make sure it really goes in there. I'm sure we all have familiarity with bubbles. And then when you carefully take it out, sometimes it pops. Let's see how.
I got mine.
Yep. So now, this is to show the flexibility of the membrane. So it's created this protective layer, but it also, it's not completely solid, right?
Yeah, it keeps popping.
Yep. All right, so now you're gonna fill in after the second part down here, the best that you can.
Oh, I did.
How the membrane, so you're gonna fill in the yellow parts. You got one?
Yeah. I got just one. I didn't get
We need this, I know it gets sticky. Get one for you, Carly.
I like the sleeve.
That happened.
Oh, I got it. So, what do we do?
All right, so see the yellow parts?
Yeah.
You're gonna fill that in as best as you can. Oops.
I don't know what analogy means.
Analogy? So how is this an analogy for how a cell membrane really works? Here, so it shows how it's not, how flexible it is. So the bubbles in here serve as the analogy for how a cell membrane works.
I don't know what's right.
So the bubbles show how it's not necessarily a solid or a liquid, but that it creates this layer.
How'd you do that so
Maybe-
I mean, for the two boxes.
we can go back to it.
Yeah.
We can fill it in as a group at the end. Maybe just need a little bit more bubbles. It's too thin. Do you want some more, Rosie, or are you good?
Okay.
Do you want some more?
Yes, please.
Can you move it closer, because I don't want to dump this.
Oh.
All right,
Oh,
we ready to go to the next page? There we go. All right, so for activity 2, this is going to show how the lipid bilayer is able to seal itself after being opened. This property allows for the cell to be semi-permeable so that nutrients can be imported into the cell and protein products and waste can be exported out of the cell without destroying the membrane. So I tried this one a few times. Hopefully it works. Sometimes it did, sometimes it didn't, just like a cell membrane will sometimes allow something, sometimes it won't. Okay, Did it,
Oh, cause
see how it goes through it, but I still have it,
that is so cool.
right? So this shows that it's semi-permeable. Sometimes, if you guys want to try it, I'll grab you each a straw.
Yes. I did first try.
I'm gonna try to get the straw through it without it popping. There you go. Oh.
I made it pop.
Well, then it's sometimes permeable, sometimes not.
Oh.
It's alright if it doesn't. It just means that it's not. There you go. Kind of neat, right?
Yeah. I made it pop.
Alright, so let's take a couple seconds to try to fill in the yellow boxes below with what your guesses are, and then again we'll did you get it yet?
It did work at first.
It did work at first. That's all that's important. I saw it work. I have more. It's okay. Alright, ready for the third one?
Yeah.
Alright, so this activity shows how proteins are embedded into the lipid bilayer. As part of the fluid mosaic, proteins don't remain in one place. So these proteins provide passageways for larger molecules to cross the membrane, kind of like a revolving door. So for this, we're going to use, here we go. Oh no, where'd my thread go? Where'd the thread and yarn go? I had thread and yarn. There we go. Alright. Can I put this on your paper? Alright. I'm gonna probably have you hand me that. Okay, can you hand me the thread? Okay. You're gonna be tricky, aren't you?
That's so cool. That's awesome.
Okay, see how it's able to move around while not going into it? Thank you. Let's try the yarn, which is a little bit heavier.
Whoa. I wish I was yarn right now.
Just floating away around on a membrane. All right, so now grab your triangles, and we're gonna have to share. Who wants the thread? Who wants?
the thread.
All right, here's the thread. And then pass that to Rosie. Pass that to Carly when she gets her.
Let me get myself situated. It just goes through.
Maybe we'll lay it on top. Lay it on top.
No,
Maybe because it's too heavy.
You could have tried. Oh yeah, get it. What have you got?
Let's see if we can grab this up.
What I think was in
Oh, we'll
Wait,
try it with the
no.
thread.
Can I try the round?
Come to you. Yeah, you can do that one, Carly. Ready?
Oh, very cute.
Again, semi-permeable.
I made it in the
Thank you.
triangle.
Awesome. All right, so now you guys can fill in the bottom of that